So in the dynamic, we have like RIP, OSPF, EHRP. RIP and EHRP, they are not in the syllabus. So still let's cover some part of them. OSPF we will start tomorrow. Okay, because we have to start the test also. Okay. RIP. RIP stands for Routing Information Protocol. And it has two versions, version 1 and version 2. Now RIP is obsolete, so you don't need to worry much about your RIP. Version 1 and version 2, some of the differences, let me tell you about them. Your version 1 was classful and version 2 was classless. Classful means support only classful subnet mask /8, 16 and 24 by default. Classless will support your VLSM, CIDR, everything. So here you can say no VLSM. Here support VLSM or CIDR. And it supports. Then your version 1 was creating broadcast messages to exchange the information. Here it is creating multicast. Okay, for broadcast, it was using the IP address, global broadcast address 255.255.255.255, and multicast, it is using 224.009. These are few of the differences. And then version 1 was not supporting your authentication. Version 2 is supporting the authentication. Some like differences are there. Okay. So same things are there, like it is classful uses broadcast, classless uses multicast. It is a distance vector protocol and it uses hop count as a metric. Hop count means counting number of routers between the source and destination. Like we took the example, right? First path was having 2, then second path was having 1, third path was having 3, if you remember this example. Right? So it will just check how many routers are there between source and destination. And the maximum hop count limit here is 15. Means if there is a network that is beyond 16 routers, that is unreachable. So in large networks, again, it cannot be used. Then your RIP uses Bellman-Ford algorithm for the communication and calculation purpose. Okay, how to calculate the best routes? It uses Bellman-Ford algorithm. And it works on port number 520, uses the multicast address 224.009, AD value is 120, and there is 4 types of timers: hello, invalid, hold on, and flush. Okay, so these timers are used for, let's say, if one network is down, so they will wait for some time, not instantly remove the route, because sometimes due to congestion also it takes time to receive the update. Okay, so hello timers, they are used to like discover the neighbors, whether my neighboring router is up or not. These are kind of, you can say, keep alive messages, through which the routers come to know that my neighbor is up or down. Okay, so if they are not getting the keep alive in the 30 seconds, every 30 seconds they are going to send. So if they're not getting, they are going to wait. And since the waiting, they'll go in the invalid state. Means they will wait for 180 seconds and they will declare as invalid, that the route is now invalid. Now, since this route has been declared invalid, it will not accept any update regarding this route for the hold on timer. Okay. And after that, it will remove the route from the routing table and then it will restart the negotiation. Okay. So this is how it is going to work. So right now I'll show you how to configure RIP. Okay. And we'll see version 2 only, because version 1 is broadcast and all these things, so we'll not use. Since version 2 is also not used, but still let's see how to configure. So you'll come to know how less we have to configure in case of dynamic routes. Okay. So, okay, let's go with the 2 routers only. So I will remove all the static routes here. So what all the static routes are there? Do show run pipe section. These many routes I have configured here. Let me copy. Paste. And in front of each, I just need to say no. Done. Copy, paste. Done. Check the routes. Do show IP route. Only one route. Correct. Okay. Now, how do we configure RIP? Configuring RIP is so easy. Say router RIP. Okay. Which version we want to use? Version 2. So version 2. Then after, which network is directly connected to R1? 12.0, right? So you'll say 192.168, 12.0 and 12.0. Okay. You'll give the command network 12.0. That's it. This is all the configuration for RIP on R1. Okay. No need to specify route for 10, 11, 10, 20, 30, and this is it. Same way, in case of dynamic routing, whether that is your OSPF, EIGRP, RIP, any protocol, okay, you will always give the directly connected routes only. Like on R2, who is directly connected? 3 and 1, 4. These 4 networks will define. Okay, see. Or if you want to check that which networks I should define, you can do one thing. Just go and check your routing table. Do show IP route. Okay. All the networks with the C code, just define them in the routing. Okay. So how many I have here? 1, 2, 3, and 4. Right. So you'll say router RIP. We want to use version 2. And then which networks? Network 10.1.1.0. Network 20. Network 30. Then you'll say network 192.168.12.0. Done. This is the routing you have to do. Now you'll see I did not I configured these networks on where? R2. Did not configure anything on R1. On R1, I did not give anything regarding 10.1.1, 10.1, 20, 30 like this, right? If you check the routing table, do show IP route. Automatically routes are calculated. Okay. You see what is the ED value? 120. What is the metric here? This is the hops, number of hops. Okay. Hop 1. Why? Because starting from source, this is the one hop. Okay. Then second thing, you see they are using both next hop, exit enter. They will always use the best way. For 10 also I have, 20 also I have, 30 also I have. Okay. Now see, should I be able to ping? 10.1.1.2. I have the communication. 20, 30. Routes are automatically there. We have the communication. Nothing to worry. Is that clear?